Hi, welcome once more. This is our second lecture we are having on algebraic expression, and with today's lesson, I'll be solving more questions with you and forming algebraic expressions. And when I am done, we'll start looking into operations on algebraic expressions. All right, let's get started. Okay, so last time, these are the examples I did not solve with you. So example 2, P and Q. P and Q are two numbers. Write down an expression for the. Okay, so this is the main question for the A. Okay. Sum of P and Q. B. Product of P and Q. And then C. Product of thrice P and twice Q. Okay, let's see how we can handle this together. All right, so solution. With the first one, so the preamble is what? P and Q are two unknown numbers. You should write down an expression for the sum of P and Q. So in mathematics, when we say sum means addition, all right? Sum means addition, and so sum of P and Q means P, all right, plus Q. That is it. Okay, so with the second part, in mathematics, when we say product means multiply. Product means multiply. All right, and so product of P and Q means P times Q. Okay, and then let's look at the last part of it. Product of thrice P and twice Q. All right, so first of all, let's reduce them. Thrice P means what? 3 times, all right, P. Thrice of P, which is what? 3P. Okay, this thrice P, okay? And twice Q means twice of Q, all right? Twice of in mod mass means what? I mean multiply. That is what we are used to. Okay, so twice of Q, 2 times Q, all right? So that is what? 2Q. So thrice P is this, twice Q is that. So product of thrice P, all right, and twice Q. That's 3P times what? 2Q. Okay, there are more examples to solve. Take a look at this one, number 3. Okay, the main question is rewrite the following open sentences using letters to represent the variables. The variables. Last time you said that variables are letters that are used to stand for numbers. Alright, so this is the first part of it. We are using number 2 because in our previous video we have already solved example 1. This is the second one. Okay, when 10 is added, to a certain number, when 10 is added to a certain number, and the result is multiplied, and the result is multiplied by 2. The answer is 40. Okay, that's the first part of it. Let's look at B. A certain number is added to 4, and the result is doubled, and the result is doubled. Okay, let me hold on with the last example, and then so we can get space to solve these ones. Okay, so this is also another set of question, different set of question you can be queried, all right, during your examination. Let me show you how you're going to solve this. All right, so the main question is, well, rewrite the following open sentences using letters to represent the variables. And the first one is what? When 10 is added to a certain number, we do not know what number it is, all right? And the result is multiplied by 2. The answer is 40. So first, denote a variable, a letter, to represent the unknown number. That's the first step you should start with, all right? So first you say that let x, well, we have been using x all the time, so let x represent the unknown number. Let x represent the unknown number. Good. Now we can now start establishing our equation. When 10 is added to a certain number, okay, some means plus, all right, the addition symbol. Likewise, added, add means addition, all right. So when 10, so this is the equation. When 10 is added to, well, we can write, let me put it here for you. So equation. Okay, so this is the equation, well, the first example. So when 10 is added to a certain number, and the certain number is x, all right, and the result is multiplied by 2. So watch closely. Assuming there was a number here, all right, when 10 is added to, say, 2, okay, the result is multiplied by 2. If you add 10 to 2, I'm saying, assuming, okay, let's use a different number. When 10 is added to 5, all right, the number would have been here, and 10 plus 5 will give you what? 15. So the question moving further, asking you to multiply the answer by 2 implies you multiply this by 2. Do you understand that? But so we will all agree to this when we should say 10 plus x, assuming the variable is here, right? The number is here, will produce a 15, all right? 10 plus x is the establishment that will basically give rise to the 15. So if there should be any other number at all right, the 10 plus this will produce the results. Either or me. The 10 plus this will produce what? The results. That's fine. So watch closely. So when 10 is added to a certain number and the result is multiplied by 2. So 10 plus this, all right, is what is going to give the result. So this is multiplied by what? 2. Either or me. Good. What is that? The answer is what? 40. That's it. The answer is 40. So this is a related equation. 2 into bracket 10 plus x equals 40. Very easy to understand. Let's look at the next one. B. Alright, a certain number is added to 4 and the result is doubled. Okay? A certain number, well, I'm using the same variable to represent the unknown number, right? So here is the equation. So a certain number, which is what? X, all right, is added to 4. Okay, and the result is doubled, and the result, so this will produce a result, all right? So it is what? Doubled. When we say it's doubled, meaning twice of that. So actually we are getting what? 2 into bracket x plus what? 4. That's it. So this is the expression for the second one. A certain number is added to 4 and the result is doubled. Either. So what are we taking from here? Usually, and the result is and all that, you put those two expressions either in brackets and then you multiply where need be, either or me, or you add where need be, depending on what the question asks you to. Okay, let's move on. There is another one. So the same 3, number 3, okay, is here. So the question moves on to this side. Number 3, C. It says that what? Twice a certain number. Twice a certain number minus 4 is equal to 5. All right. Well, this was really clear. Okay. All right. So you can pause your video and do this yourself, and then you later on come and check the solution. Okay, so with this one, twice a certain number, we are using the same x to represent the unknown number. All right. So twice a certain number, that's going to be what? 2x. All right, 2 times x, that's 2x, minus 4. This is clear, all right, is equal to 5. That is it. Twice a certain number minus 4 is equal to 5. So this is it. This was easy to represent. Okay, how about this? Assuming it was put this way: twice a certain number. Twice a certain number subtracted from 4 is equal to 5. How are you going to put this one? So this is a new one I'm trying to give you. All right, so in this case, twice a certain number is what? 2x is subtracted from 4. In our previous example, we did a thing like that. It's subtracted from 4, so meaning 4 should be here. Then you take twice of that certain number from 4. Either is equal to 5. So that is it. Normally, when you see is in word equation just like this one, it means equal to twice a certain number subtracted from 4. So take note of these expressions. Subtracted from is taken from, all right, and then when they go clearer, minus either of me. How about this one? Okay, you in our subsequent example, I'm going to do that with you, don't worry. So the next one, well, I'm solving these questions with you because they are not all the time the same, all right? They appear differently, and I want you to know. So anywhere questions can be brought in your examination, you'll be able to answer each one because it's not going to be new to you. Let's solve the subsequent ones here. All right. So I'm cleaning everything. Okay. I'm cleaning everything. You can play back to have them. Okay, so okay, so this is our fourth example. Good. Write an expression for each of the following statements. Okay. So A. So this also appear differently. It's not the ordinary ones we've been doing. So Amma is X years old now. Good. How old was she? 6 years ago? 6 years ago. How old will she be eight years from now? All right, B. If Isaac's age is now 17 years, how old will he be in 10 years time? Okay. All right, there's one more, but let's finish this one. Okay, so the A part is in two sections. All right. You realize that this particular question is about ages. All right, so let's do this. I like to practicalize that with our daily living. Okay, write an expression for each of the following statements. All right, write an expression for each of the following statements. A. Amma is X years old now. How old was she 6 years ago? That's the first part of it. Solution. So like I said, I like relating it to, daily scenarios. All right. So assuming I am, let me say I am 16 years old currently. Assuming I'm 16 years old currently. 16. I'm 16 years old currently. All right. So how old was I 6 years ago? All right. If you are able to represent this so well, you'll be able to tackle this. How old was I 6 years ago? So it's obvious that 6 years ago I was 10 years. All right. Yes, your guess was good. It's 6 years ago, I was 10 years. How do you get a 10? So it's clear. You held on to my current age, which is 16 years. All right, my current age, and then you rather subtracted the 6 years, the year I gave you 6 years ago from what? My age, and that is what gave you 10. If you know the roots of integers so well, realize that 6 representing the years ago I gave you. All right, 6. If you subtract that 16, my age, from it, you are not going to get 10, but you get negative 10. So this is not what you did. You actually did this. All right. So again, I'm 16 years of age now. How old was I 6 years ago? So it's obvious you always hold on to my age and then you subtract the years given in a question from my age. Good. So we can really extrapolate to the idea here to this. So so this is the first part of it. First part. So Amma is X years old now. All right. How old was she 6 years ago? So 6 years ago, well, let's copy from here. So 6 years ago, how do we normally get our answers? We usually hold on to her age. In this case, they said she's X years old now. And then what we do is that we subtract the years given from her age. So 6 years ago, she was X minus 6 years. Now, again, I'm 16 years old now. In 6 years' time, what will be my age? Well, we can change that if you think it's confusing. 7 years' time, what will be my age? Well, 7 years' time, meaning you definitely hold on to my age and then you add 7 to it. Either me. And what are we getting? I guess we're going to get 24. Either me. No, 23. Good. All right. So 23. You add the years, all right, to the years given to your current age. Good. Well, addition is commutative, so whether you put it as 16 plus 7 or 7 plus 16, you definitely get the same answer. But I recommend you do this so it will be easier for you when you're thinking about subtraction. So in 8 years' time, all right, 8 years' time. So in 8 years' time, her age is going to be, you take her current age, all right, and then you add 8 years' time to it, all right. So how old will she be 8 years from now? So that's going to be X plus 8 what? Years. Like I said, with addition, whichever way you put it is right. But this is what I recommend. You're a student, so this is what I recommend. All right. So let's come to the B part of it. You can pause the video and solve that, and then you play back to confirm if your answer is right. But I believe all of you will be able to score this. So the B part of it, okay. So Isaac's age is now 17 years. How old will he be in 10 years' time? Well, so in 10 years' time, all right, his age is going to be 17 plus 10, all right. So in 10 years time, all right, which is what? 27 years. Okay. So that is it. All right, so let's try the next one. Okay, let's take a look at this very one. So it's a continuation of this. Example 4C. A boy's age is X years. Okay. And his father Yeah, and his father's age is 5 times as old. What will be the sum of their ages in 1 year's time? What will be the sum of their ages in 1 year's time? Okay, so solution. Okay, so if you understand this, what we've done so far, then this will be what will challenge your understanding skills. All right, so a boy's age is X years and his father's age is 5 times as old. So questions like this, this appears somewhat different. All right, questions like this, I advise you put them in steps. All right, so currently, all right, so boy's age, so currently boy's age will be what? So it's equal to what? X years. Good. And then what's next? And his father's age is 5 times as old. So father's age. So if the boy's age is X years now, his father's age is going to be what? 5x. Because according to the question, the father is 5 times as old. 5x in years. Okay? In years. Good. You see, I advise you put it in this way and you'll not struggle. What's the next one? What will be the sum of their ages in 1 year's time? So back at it. So this is their current ages. Now, in 1 year's time, then you start again. Boy's age. What will be boy's age? Well, if you've been able to produce the answer, it's fine. But I would like us to make some scenarios and then understand before we move on. So this is just like saying what will be the boy's age in 3 years' time. So if the boy's age is X, of course, in 3 years' time, his age is going to be X plus what? 3. Now, it's no more 3 but Y. So it's going to be what? X plus Y. In 1 year's time, this is the boy's age. Alright. Of course, age is in years. Alright. Okay. Now, what will be the father's age? Now, mind you that the father's age is currently 5x. So in 1 year's time, the father's age is going to be what? 5x. Alright. Plus y. Assuming the father was 9 years, and I asked you to find his age in 3 years' time, is it not going to be 9 plus 3? And so it's 5x plus the 3 year is rather y year, so 5x plus y. So in 1 year's time, the boy's age is x plus y, and his dad's age is 5x plus y. And now, if they ask you to find out the sum of their ages in 1 year's time, of course, this is going to be our equation. So equation will be equal to in 1 year's time. Equation implies what? So you're going to have x plus y, all right, x plus y adding up to 5x plus y. Okay, so in 1 year's time, this is the sum of their ages. Well, at this point, if you leave your answer this way, I'm going to give it to you because with the way I'm structuring the lesson, I've not started addition and subtraction with you. So if you leave your answer this way, I'm going to give it to you either. But very soon you'll be able to solve this either. So we'll start grouping like terms. X plus here is going to be what? 5x. Then plus y. You group like terms. X will match up to X, any component with X. Y will match up to any component with Y, all right? And over here, you get 6X. Very soon you understand, plus 2Y. So you can end here and reserve this answer for our subsequent lecture. Over there, you get to understand why I did this grouping, and then also I arrived at this. But before that, I've taught you what like terms are. Alright. Once the power on the letter and then what? The power on the variables are the same, is regarded as liked ones. Alright. And so you can group them regardless of the number in front. So over here, the power is 1. Alright. So whether there is a 5 in front of this whatsoever, once is x here, that is in the allied terms. That is similar for the y. All right. Okay. So we are done. I'm pretty sure with any other example you meet under forming algebraic expressions, I mean in word equations, you should be word expressions. Sorry, you should be able to produce answers. Good. Like I promised you, we are going to do operations on algebraic expression, and with this part of this section of video, we will be doing addition and subtraction only. The rest will be tackled in our subsequent videos. So let's start. Let me rub it. Okay, I reserve this for anyone writing. Okay, so operations on algebraic expressions. So we'll start with addition and subtraction. Alright, so considering operations, we'll deal with the 4 operations in mathematics. So addition, subtraction, multiplication, and division. Good. So we're doing addition and subtraction first. So over here, you add and subtract like terms in order to produce a single term. Okay, you add and subtract like terms in order to produce a single term. And with this very one, I would advise before you start solving, group the like terms first before you start adding or subtracting. Okay, take a look at the following examples. Of course, I'll solve some with you, and the rest you try to see if you can do them. Simplify the following algebraic expression. The first part, A. 6A plus 7A plus 8A. B. 2B plus 3B. Well, let me put about 4 of them here. 6K plus KM plus 2K plus 12KM plus 3K. And the last, well, that's not the last, but this, I want to add up this and then we can start solving. Okay, so solution. So I said that before you start, group the like terms. Well, in the first example, they are already grouped. I told you terms are said to be liked ones when the variable, all right, and the power on the variable are the same. All All right, so over here is A, so they are like terms. So in addition, what do we do? Once you discover terms as liked ones, you just add the numbers in front, which we call them what? The coefficients. We did it the other time. So you add them. So you add the coefficient. All right, so here, what are we getting? So 6 plus 7 is what? 13. And 13 plus 8 is going to give us 21, isn't it? So you're going to have 21. Then you top it up with the common variable they are all sharing since they are the same. So you're going to get what? You will be getting 21a. How about the B part of it? Have you gotten an answer yet? The B. Okay, so over here, they are already grouped, okay? So B, they are the same. And so you just add the numbers in front, giving us what? 5b. Please have it here. All right, let's go to the C part of it. So over here, you group like terms. So you're going to have 6k. Group it to any k. That's what? 2k, all right? Because of course, the power is 1, 1. And then is there any other k? That's what? 3k. All right. So the next thing is that there is a km. So km, of course, we don't care about the coefficient. What matters is what? Km. So 12 km. Well, before you start solving, you can count them to see if you really tackled every portion of it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now you can add them. So since all these are keys, we can add them. 6 plus 2 making 8. 8 plus 3 making 11. So you have 11k, then plus 1. km, all right. The coefficient of km is 1. We usually do not write it. When a variable is standing alone, there is a coefficient which is 1 in front. So 1 plus 12 is what? 13. So 13 what? Km. You cannot add these two because the variables attached to them are not the same. This is k, this is km. I guess you found the answer for D already. It's subtraction. Can you try that and let's see? So over here, they already like terms n. So you can now easily subtract, isn't it? 14 minus 3 is going to give you what? 11, isn't it? Good. And 11 minus 11 is what? 0. Then you attach the variable, but 0 n is 0, so it's preferable to leave it this way. Yeah. Any question? Okay, so if you have any question, you can leave it in the comment section. There are others I want us to do. Like I always put it down. I would like us to solve more questions. All right, so this D, right? So let's see E. What E has for us? So E is what? 22x minus 4xy minus 7x, then plus 3xy. So over here, you group, okay, sorry, let me continue. 2c plus 5c plus, no, minus 9c. AFG, what do we have? 7k plus 2k minus 6k. H, we have 20x minus 5xy minus 6x. And well, there's the last example I could provide. This is what? 14h minus 2l minus 2h. Okay. So we have 22 minus 4xy minus 7x plus 3xy. Actually, it's 22x, not just 22. So you group items, alright? 22x can stand there. Is there any term with an x? Yes. That's what? 7x. All the time when you're carrying a number, the sign in front of it must be carried together too. Alright, that is its ideal sign. So over here you have what? Now I'm done with the x, so let's go to the xy. You see, when I was carrying the xy, I made sure I carried it together with the sign in front. So there is another xy, which is what? Plus what? 3xy. That's the sign in front. Okay, so we can now start to do what? Solve. Alright, so 22 minus 7, what are we getting? 22 minus 7, so you're gonna have 15, isn't it? 15x, then minus xy plus 3. So, well, let me explain the rules of integers to you. When you have a negative in front of a number, we say you are in debt, okay? And then when you have plus in front of a number, it means you have more or less like money either. So assuming you are in debt, you have a debt of 4 either, and then you have an amount of 3. What do you think will be the new establishment? You have a debt of 4 and you have an amount of 3. 3 will go and pay the debt of 4. Either it will pay 3 of that, and of course you'll be left with 1. 1 is what? Is it not a debt? Yes. So you have 1, but 1 is a debt, so you have to put the minus in front, right? So 1xy, or in fact 1xy is the same as xy. 1 in front of a number, I usually do not prefer writing it. I don't mean you should repeat a step, but I want this to be there for you to those reanalyzing the explanation given, so you don't get missing. But I prefer you write this, alright? Okay. This is a layman's solution. Alright, so F, you have group items. Of course, it's already grouped. C, alright? So 5 plus 2 is what? 7. So 7 minus, okay, so you basically getting 7c minus 9c. And 7 means you have, minus 9 means you owe. You have a debt of 9. So 7 will go and pay 7 out of 9. And you'll be left with 2. And 2 is still debt. So negative 2, isn't it? So with the F, you're going to get minus what? 2c. In fact, if you analyze it that way, it's going to be easy for you when you're solving integers. I prefer to do the other ones here. So the G. So K, so they are the same, isn't it? And so you can add them and subtract, alright, with ease. So 7 plus 2 is 9. So now you have 9 minus 6. That's what? 3. So you have 3, then because they are all the same, you just attach the common variable, the all bear 3k. Alright. Let's come to the H. Okay, so over here I have to group like them, isn't it? So the 20x will stand on its own, and then minus 6 should be carried to it, alright? So minus 6x. And then now the 5xy should be left alone. What sign is in front? Minus. So minus 5xy. And now you can add 20x minus 6x. you're going to get, I guess, 14, isn't it? This is 14x, then minus what? 5xy, because it cannot be added. Alright. Can you pause and solve yourself? Pause and solve that yourself. And then you can come back to verify. So you have 14h minus 2l minus 2h. So you group like terms. You're going to have 14h, then minus 2h, and then minus 2l. And this is going to give us what? That's 12h. Alright. Then what? Minus 2l. Alright. Students, that's far. These are the various questions you can be having under addition and subtraction of algebraic expression. And with this, I can boldly say you can solve any question under this category. In our next lecture, I'm going to discuss multiplication and division of algebraic expressions. So please do your best to watch that too.